Now let us see the second application of your dimension analysis, conversion of one unit from one system to the other. This can be understood in a very easiest way. Let us consider this question. 2.2 dyne is equal to dash Newton. So you have to find out how much Newton 2.2 dyne is. Before that, the process I am just explaining how you can convert. Let us understood how we can measure this. See, dyne is a unit of force, so also in Newton. But two units, they belong to different systems. Newton belongs to SI unit of force. Dyne is a CGS unit of force. So first you identify which physical quantity is involved. Here the physical quantity is your force. So write down the dimension of force. Dimension is m1 L1 t minus 2. The general form means here m L t is sufficient to define this physical quantity force. So in general I have written m a into the power a, L to the power b, t to the power c. Means the dimension of m here it is 1. Here it is b is equal to 1, c is equal to minus 2. Clear? So the concept here is, suppose you are measuring a physical quantity under one unit and also on second unit. There are two units, first and second. So your value means N1 E1 must be equal to N2 U2. Means the value of that physical quantity won't change if you change the system of unit or system of unit of measurement. Only the numerical value will change, N1 converted to N2, and the base unit will change. But the entire product N1 E1 must be equal to N2 U2, which will give you the value of your physical quantity. This value of the physical quantity is not going to change. Numerical value will change and the unit of the quantity will change. Similarly, while writing the dimension, if we change the system of unit, the dimension of physical quantity are not going to be affected. This formula can apply for the dimension too. So what is the general formula here? N1 is the numerical value in one system, and this is M1 L1 T1. They are the base unit under this system, and the dimension here it is A, B, C. So M1 multiplied with the dimension of physical quantity under one system, first system, must be equal to the numerical value in the second system with the base unit raised to the dimension in that system. M2, L2, T2 are the base quantities in the second system. Clear? All of you just see in the left side and right side the dimension ABC, here the dimension is ABC. It is not going to be changed, well, though you change the system of unit. So we have identified. Now you see we have to ask here to find out the numerical value under SI system. Clear? So this is the procedure. You write down the two systems involved. Here it is, one is SI, another one is CGS. So under SI I took M1 L1 T1 as my base units. So M1 is 1 kg, L1 is 1 meter, T1 is 1 second, and N1 we need to find it out. Similarly in CGS system, M2, L2, T2 are 1 gram, 1 cm and 1 second respectively, and M2 is 2.2, which is given. Now if you compare this equation, and I need to find out N1. So if you keep N1 LHS, take the entire term and divide here, so which I have done here. N1 is given by N2 into this term. Now you see here M2 and M1 both are raised to power A, L2, L1 both are raised to power B, T2, T1 both are raised to power C. So I have separated them, M2 by M1, L2 by L1, T2 by T1, power here A, B and C. Now what I have done, I just put their base values, their values under that particular system. M2 is 1 gram, so that's I put 1 gram, M1 is 1 kg. So L2 is 1 centimeter, L1 is 1 meter, T2 is 1 second, T1 is also 1 second. 1 second got cancelled, so the power means 1 power anything will be 1, that is carried here. Now here N2 I put it is 2.2. Now all of you just see, again it is kg, it is gram, it is in kg. So 1 gram by 1 kg is 10 to the power 3 gram, and here it is in centimeter and here it is in meter. So 1 centimeter and 1 meter we know 10 to the power 2 centimeter. Means 1 meter is equal to 100 centimeter. 100 is 10 to the power 2 centimeter. If you calculate, see here it is 1 by 10 to the power 3, gram got cancelled here, and centimeter got cancelled. So your value is 2.2 into 10 to the power minus 3, and here it is 10 to the power minus 2. And your answer is 2.2 into 10 to the power minus 5. So finally I am going to get 2.29 is equal to 2.2 into 10 to the power minus 5 Newton. So which is the numerical value. Now students, this is the last application of your dimensional analysis. The application is to derive a new relation among the physical quantities. This thing can be done. Let us consider a question. We know the derivation, the time period of a simple pendulum. The question is related to that. The time period of a simple pendulum, let us the time period of a simple pendulum depends upon the length of the simple pendulum and the mass of the bob there and the acceleration due to gravity. Establish a relation between them. So your job is to do identify the quantities involved here. The quantities here, it is time period means time, length of the simple pendulum, here it is length. Also mass of this bob means mass and is one other quantity, and acceleration due to gravity means acceleration. That's why I took the quantities here. The symbol time period for that symbol I took it is t. Its dimension is t1. L, length of the simple pendulum, so dimension is L1. Mass of the bob, which is small m, I have taken the symbol, and its dimension is m1. Acceleration due to gravity is small g, and its dimension is L1 t minus 2. Now let us start the derivation with this. According to the question is given, time period depends on the following quantities like this. So we do not know how the physical quantities, how the time period, what power of the physical quantities, it is unknown to us. That's why we took, suppose time period is proportional to L to the power A, M to the power B and G to the power C, as it is unknown. So our aim is to calculate this value A, B and C. Now this equation actually I have written here based on this question. Here if you know time period depends on these quantities, then we can derive. So that idea you must possess. Clear? So now if we can combine this, all these three, I can write here, I can take a proportionality constant k. So here I can write, which implies time period t is equal to some constant k, L to the power A, M to the power B and G to the power C. So that I have given equation number 1. Now you do one thing, write down the dimension of all the quantities on LHS as well as in RHS. So here the dimension of t is t1 I have written here. So it is k. And the power of L is L1 because the dimension of L is L1 here. So it is L1 power A, M1 power B, G, the dimension of G is L1 T minus 2, the power is C. Now you just multiply, you just find out the power. You multiply A with A and find out the exact in terms of unknown quantities. So here it is T1, here it is K, and here L power A, power your A means L to the power A. So here it is M to the power B and it is L to the power C into T to the power minus 2C. Now as the quantities involved here is M, L, T, so let us try to write the LHS in terms of all the three dimensions, basic dimension M, L and T, as maximum M, L, T are used in the right side. As you see here only time is there. So that's why I have written M to the power 0 and L to the power 0. Means they are not used to express the time period. So the dimension here is M0, L0, T to the power 1 and here it is K. Here I have just again arranged in this manner MLT, MLT form. So here M power B, I have written M power B. L power, here it is A and here it is C, means A plus C. L to the power A plus C. And the time period is T to the power minus, the time is T to the power minus 2C. Now, as we know, for a correct physical relation, the dimension of both the sides must be equal. So now what you do, just equate the dimension of physical quantity means on both the sides, LHS and RHS. Clear? So here all of you just check, the power of m is 0 and the power of m is b. Means if you compare this, you are going to get b is equal to 0. And the second one is, if l to the power a plus c, here is 0. If you compare l to the power a plus c to l to the power 0, you are going to get a plus c is equal to 0. Now t to the power minus 2c is equal to t to the power 1, the third one. So if you check it, so you are going to get minus 2c is equal to 1, and if you compare, c is equal to minus 1 by 2. So here we got b is equal to 0. In this equation, a plus c is equal to 0, and in this equation we are directly getting c is equal to minus half. Now you see here, in this equation, equation 3, from equation 3, we know a is equal to minus c. So c we got minus half, so minus of minus half is equal to plus half. So basically we get the value of a, b, c like this. A is equal to plus half, b is equal to 0, c is equal to minus half. Now you take the values of a, b, c from equation 2, 4 and 5 and substitute in equation number 1. So in equation 1 becomes t is equal to k into l to the power half, m to the power 0, z to the power minus half. Because here l to the power a, m to the power b and g to the power c. So I have just substituted the value of a, b and c. Got l to the power half means root over of l, g to the power minus half means 1 by root over of g. So if you write here, and m to the power 0 is 1. So your answer will be t is equal to k into l by root g, or t is equal to k into l by g root over. But the actual formula for the time period, here the value of k is 2 pi. This is the limitation of your dimensional analysis. By this method, we will be unable to find out the value of this k, or the proportionality constant. This can only be found out experimentally. Clear? So t is equal to k root over of l by g. It is a derived formula, but this dimensional formula is helpful to just give to just find a one new idea related to the physical quantities or involved. So this is the required formula. Similarly, so many formulas are there, so many questions will be there, but this is the process you need to follow. Clear? Thank you.